Welcome back to another great episode of Dr. J Radio Live. Of course, I'm your host, Dr. J, broadcasting from the City of Angels. And this time we are doing not just only a live interview, but also a live real video interview if you on YouTube are paying attention to this. Now, today is a very esteemed guest, someone who I'm very proud to call my friend. And he is really someone that everybody should be paying attention to. As a matter of fact, I know that finally some scientists and some journals are finally paying attention to this genius's work. He is a genius. He is a unified physics, and he is really worked on so much with the Resonance Academy that we'll get into that. So let me just introduce you because I've already dropped enough hints on who it is. It's the one and only Mr. Nassim Haramein. Nassim, welcome back, dear friend.
Oh, thank you. It's great to be back.
It's always a pleasure, my friend. Always a pleasure. Now, you were born in Geneva, Switzerland, a very, very beautiful city. Now,
hmm
bef- at what age did you start to pay attention to physics? When did you think that you were going to be involved in physics?
Mm. Um, Specifically physics, not until much later when I was in my mid 20s, but when I was a child, I was very interested in understanding the physical world and understanding how it worked and how I could, understand not only the physics of our reality, but how it get organized, how it self-organizes in biology. Why atoms make biology. It's a good question. Each atom is made, each cell in the body, for instance, of a human is made out of 100 trillion atoms. They all self-organize in this very complex system. And then there's 100 trillion atoms in the human body. I was really interested to understand how this all happens and eventually how this whole self-organizing system become self-aware, which was even more mysterious. Like, how does it become conscious and all this? So all this were really fundamental questions I had from the start. I think many children have them, but I'm very hard-headed. When I start with something, it's hard to get me to stop. So I got really into it, and I ran my basically my own little research investigation for most of my childhood and into my 20s, and eventually studied physics deeply and intensely for some 30 years, and I believe I found some very profound answers to some of these questions.
Now, what was some of the first theories that you were looking at? Because I would think growing up, where Einstein had left off, he was trying to, for instance, the final theory that he was trying to complete, right? A theory versus what's an actual fact has to be tested and tested and tested,
Mhm,
and each having the same outcome with different
mhm,
kinds of tests.
mhm.
Wasn't he trying to unify all the field of fear, unified. Can you explain the unified field theory? That I.
Yeah, well, as a result of his equation on relativity that describe gravity as a curvature of spacetime, there was a split as well as a result of the work that he did in quantum physics. Like most people associate quantum physics or the father of quantum physics with Max Planck, which is true. Um, but they don't necessarily know that the contribution of Einstein to quantum physics was extremely significant, including the photoelectric effect, where he described the photon for the first time, and so on, which he got the Nobel Prize on. So people think he got the Nobel Prize for relativity. He didn't. He got the Nobel Prize for the photoelectric effect, which is really one of the bases of quantum theory. So he started both sides, the gravitational cosmological side and the atomic quantum side, and the two theory don't agree. One says that space-time is smooth at the cosmological level. When it curves, it's smooth. And the other one says, no, 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 no. The universe is quantized into little bits. Everything is in little bits. And so the two theory don't agree. And so there's not really a good way to put gravity into quantum theory as a result. And so Einstein worked on unifying the fields, that is unifying the field of gravity with the strong and weak force at the quantum level, um, and uh, and the electromagnetic field as well. So the unification of all these fields with one theory that would describe all of the scales is what he worked on, and until literally the day he died. Like he was writing equations, working it out the day that he passed. So it was a big thing. And then after that, it was kind of ignored. I mean, Einstein was pretty well ignored after he wrote relativity. He didn't agree with some of the conclusions that emerged from quantum theory, and but they ceased to listen to him. And he tried to put ether back into physics and so on. But basically, at the end of his life, he had, I think he was extremely close, especially when he tried to put the ether back into space time, and but he was not able to complete it. And after he passed, it became accepted that, well, there's just two theories, and there's a theory for the big stuff and there's a theory for the small stuff, and we don't need to find a unified field theory. And it became almost voodoo to work on unifying physics, and was seen as inappropriate because it sounded like arrogant, because if Einstein didn't figure it out, why would you, right? And so, it was, I remember in my earlier days when I would go to physics conference 25 years ago and I would say I'm working on unifying the fields, they'd be like, oh, whatever, and many of them would say, why? We have two perfectly working theories that are very powerful. Why do you want to unify them? And it's like, it's simple. It's like big things are made out of small things. So there's gotta, where does it go wrong in between the two? It's like there's gotta be something that describes the whole thing. The universe is not separated into two different ways of doing things. It's doing one thing and it's doing it really well, right? And so I looked for that thread. I looked for that one thing, like what is it that it's doing that's giving all these results at two different scales, and at all scales. And I finally found it.
And is this the toroidal fields they were going to talk about, where it literally links up to what an atom can do, how an atom operates with the, I guess you could say the energy circling around and going down to the center of the vortex of it, also as well as even cells or even oceans, planets, and even the whole solar system and universe for that matter?
Yeah, I mean, the topology of the torus is related to what I found, but mostly what I found, what what finalized the unification. And I just published this equation that I had started publishing in 2012, called the holographic mass solution, which allowed me to predict very accurately the radius of the nuclei of atoms, the radius of the proton. It predicted it more accurately than the standard model by 4%. Actually, to this day, it's the only theory that properly predicts the radius of the atom, the radius of a proton, which is really, really important in physics because it sets, all the other constants, and well, a bunch of different other constants, but as well, um, in the last few years, so I published that for the proton. Then I found the same solution applied to the electron and all the table of elements, and I published that. And then just recently, I published as well the same equation applying to the universal size. So, like, imagine an equation that gives the correct answer for a whole bunch of things, for the proton, the electron, the table of elements, the strong force, all this stuff at the quantum level. And then you apply the same equation to the universe, which is a huge scale difference, right?
Very.
From a proton universe, right? And it applies just right. It gives you the right answer. We got extremely precise, good answer for the critical mass of the universe. Got rid of dark matter and dark energy. I mean, it solved a lot of things cosmologically. And now this is unpublished. So this last paper was published in Physics Essay, which is a really good journal, peer-reviewed journal. Very excited about that. Um, and and it's powerful. It's a powerful solution. And and now unpublished yet, we've been able to fill the stuff in between the proton and the electron and the universe. We were able to like apply the same equation for clusters, superclusters, galaxies, stars, so all the stuff in between, and it comes out just right, and it's just remarkable. It's beautiful, and so your question about the torus is part of it, but that's more just the dynamic of what happens. But basically, the source of the equation, the discovery, is that space-time is not smooth. It's quantized. It's quantized at the Planck scale. It's just that the quantity is so small. It's billions of times smaller than an atom. So it appears smooth to us. I'll give you an example. Like the bath water in your bath appears smooth to you, right? When you pull the plug in your bath, it makes like a little spiral. And if you put a rubber ducky there, it will appear like it's rotating or in orbit, right? This is very much what Einstein described. And the curvature of the water going down the drain, that's the curvature of space-time, described by space-time in the analogy. And of course, the rubber ducky orbits if it's closed, but if you bring it further, you won't see it rotate, right? So that's, in the water surface, when you look down, you will see it looks perfectly smooth, right? But if you look at the quantum scale, the water is not smooth. It's made out of atoms. It's made out of particles. It's made out of molecules. All this, so depending, if you're looking at something from too big of a scale, it might appear smooth, but in fact, it's quantized. So this analogy is great because basically what I found is that space-time, or the space between you and I, the space between everything, and the space inside the atom is 99.999999% space. The space is full of these little quantum fluctuation, these little photons that are occurring at the Planck scale, electromagnetic photons. And when these photons spin together, right, in a region of space, we call it a proton, we call it an electron, we call it a star, we call it a galaxy, we call it a cluster, a supercluster, or a universe, right? Depending on how many of them are orbiting together.
Now, what are the implications of some of these theories that you've been able to prove, or essentially lay out, that other people haven't been able to prior to your discovering them?
Well, the main difference is getting rid of the assumption that space-time is empty. Mm-hmm. See, like what happened is that when Einstein wrote these equations, before that, Maxwell had described the electromagnetic field as oscillation of a field of energy. He assumed that space and time was full of this energy that he called the ether, the luminous ether, and that this ether, when it oscillates, made electromagnetic. And he wrote his equation based on that, and it worked, right? It's just that when Einstein wrote relativity, general relativity, they felt, well, we can replace that with space-time and eliminate the ether theory. That was a huge error. And I've been saying this for 30 years, and finally, some of the greatest physicists on the planet are starting to, agree with this. There's a great talk by Frank Wilczek. He's a physicist that received a Nobel Prize in physics. It's called The Materiality of the Vacuum. You can find it on YouTube. It's a great talk where he goes through the history of Einstein and Maxwell and all this, and he shows that Einstein actually screwed up when he removed the ether and wanted to rectify that problem later on, but they didn't listen to him anymore. But he changed his mind. He actually said that general relativity, is inconsistent without an ether. But this ether, I discovered it, of course, when I studied Maxwell's originals equation, but as well when I was studying quantum field theory, because although they removed it, it kind of creeped itself back in because the physics just won't work without it. It's just a changed name. All of a sudden got called vacuum fluctuations or 0 point energy, which you might have heard of.
Yeah,
And
absolutely.
yeah, and so it creeped itself back into the physics because when they were working out quantum theory, when they got to quantum field theory, trying to figure out the structure of space at the quantum scale, they realized it was full of energy, and not just a little bit full of energy, really, 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 really full of energy. And people might say, "Well, what is he talking about? Why?" Space is not full of energy. I can tell there's no energy. Well, think about it. Right now around you, in the space around you, it's full of electromagnetic fields. It's full of microwave and X-ray and background radiation from the galaxy, background radiation from the universe. I mean, it's full of that radio waves. There's all the radio stations in there. I mean, it's really dynamic. Now imagine that there's electromagnetic, and you don't feel these electromagnetic fluctuations, right? Well, imagine there's some of these fluctuations that are so high, so small in terms of their wavelength, right? Imagine there's shorter and shorter and shorter wavelength, right? And higher energy levels. And then and you get into gamma ray and all this, and you can imagine you can go way further, all the way down to the Planck scale, and that's where you find that the structure of space-time is actually fluctuating with this amazing amount of energy. And basically what I found is that all of the material world, and most likely consciousness, is the result of that energy that's permeating everything.
Really? So I know most people are going to question this and wonder how consciousness can fit into physics. What would you say to those people who are questioning it? Those mainstream people who wouldn't say necessarily, uh, maybe even call this fringe science when clearly it's not. It's real science.
Right. I mean, not so long ago, 20 years ago, in physics conference, if you said the C word, you'd get kicked out right away. I mean, it was not acceptable. You could say the F word all you wanted, but
Yeah.
but don't say the C word. And I was told that thing by one actually very prominent physicist that, the standard equation is better because it doesn't require consciousness. And I remember, I think my answer is do you realize you just insulted yourself? Because of course, consciousness must be part of the equation somewhere when you unify the fields, because you're the one writing the equation. And so without you, how is matter writing the equation? How is it that you're even observing the universe? Observation is required in all physics. You have a frame of reference. You got to define a frame of reference. So ultimately, consciousness has got to be involved at some point. Interestingly, the whole idea about consciousness not being part of physics is completely reversed now. And it's the new thing for physicists to retire and work on trying to figure out consciousness. It's totally acceptable now. and but clearly, but how does it fit in the equations I wrote? Well, when you look at these little quantums of information of fluctuation in the vacuum at the quantum scale, you can think of these little quantums of oscillation as little bits of information, just like you put bits of information on a hard disk. That's basically you're making a little fluctuation in the magnetic field of the hard disk in that region, and we call it a bit of information. You put enough bits of information together, and you can get an image, or you can get a program to run, or whatever. So think of this space, right? So now what I've told you is that space is not empty. It's full of this energy, and it's permeating everything. It's making all the atoms you're made of, all the material world you're seeing, which is 99.99999% space, right? So basically what you call the material world is just solid space, right? It's space that has a little electromagnetic radiation that makes it so it bumps against each other, right? So now think of that field that's doing all this as a field of information, right? Because think of every little bit that makes all this organization as little bits of information working together to make something complex. So then so now you have bits. Imagine, so you have bits spinning together, and it's a lot of them, billions and billions. Like for one proton, the equation that give me this so precise radius of the proton predicts that within a proton there is 10 to the 60th of these bits. Wow. So that's a lot. That's billions and billions and trillions, right? Because they're really small. Planck oscillations are really small. If you grew one so it was a grain of sand, the proton would have a diameter from our sun to Alpha Centauri. Wow. Right? So they're really small. So there's a lot of them, and when they spin together, they make up like things like protons, electrons, and stars and galaxies and all this. But if you think about it, like think about like a smoothie of these little plunks spinning, right? You'd have some of them that are going out, and you'd have some of them that are going in, right? In the rotation, just like a fluid. Well, that means that there's a feedback of information. There's stuff going out, there's stuff going in. Think of yourself like throughout the day, you're gathering information through your senses, right? You're interpreting the information, and then you're acting on this interpretation, which is like the information going back out. So there's a feedback of information, and technically, to really simplify it, the equations say basically the bits that are going out are electromagnetic radiation, and the bits that are going in are gravitational force. And basically this feedback can create higher and higher levels of complexity, just like a fractal equation. In a fractal equation, you have, you take the result of the equation, you feed it back onto itself, and then you get iteration and iteration, and very quick level of iteration, you have really highly complex systems, right, that are self-organizing. And so you can see that in nature everywhere. Nature acts like a fractal, so there's got to be feedback. So so let me simplify it. If there's feedback in space-time of this information, then the space-time would organize itself into more and more complex things to eventually make biology. And then when the biology was complex enough and there was enough data going through the feedback, the system would become self-aware, which is knowing you're you, which is a feedback, right?
Yes.
And so now all of a sudden the basis of consciousness become, very, very describable in terms of physics, in terms of the mechanics of information moving through a field. All of a sudden, you have the key to how consciousness emerge out of the material world.
Now, let me ask you about gravity. How does gravity play a role in space time? Because I've heard theories that if you are able to affect a gravitational change, then you could essentially create a wormhole or other things like that.
Sure. Well, the first thing is that gravity is not known. Meaning, we in standard theory, right? Um, Einstein told us that gravity is the result not of a mass itself, but a mass acting on space-time around it, right? So from Newton thought that gravity was a property of the object itself. Einstein said, no, gravity is the result of space-time around the object curving, like the rubber ducky and the drain example I was giving earlier, right? So you pull the plug, the water is going down the drain, and the surface of the water appears like it's curving, and of course, a rubber ducky starts to orbit around it. The usual analogy is that you put a ball on a trampoline surface, it will curve the trampoline. If you put another ball there, it will appear like it's attracted to the first ball. But the thing is that that's very nice, but it doesn't tell you what gravity is. Why? Most physicists in the world will agree Einstein didn't tell us what space-time was made of. So what is curving? Right? Like, if you don't know what's curving, you don't know what gravity is. You just know that it's the result of this mysterious thing called space-time curving. So, and that comes back to like missing the mark by getting rid of the ether. But basically, now we're discovering, and WorldCheck is on it as well, and others, that including Sutskin and many others, like these are some of the biggest names in physics, the greatest physicists. They're excellent physicists, they're excellent thinkers, and they're all coming to this conclusion: space-time is quantized, it is acting like a fluid, and so you can imagine that if you don't know what space-time is, then good luck trying to affect the gravitational field. You don't know. It would be like in your bath trying to curve the surface of the bath by tapping it, right? Or by trying to put energy in it. And if you calculate how much energy you'd have to put in the water for it to start curving on its own, it would be like all the nuclear power plant on the planet wouldn't even create enough curvature to like lift up a spoon off the table, right? It's not like the numbers are huge. So in general, physicists say it's not possible to affect gravity, right?
Yes.
Because think about it, like if you wanted to like make me levitate, you'd have to make like an energy effect above my head that would overcome the gravitational field of the Earth. So that's a lot of energy, right?
Something that would be stronger than the Earth's gravity, essentially.
Right,
Yeah.
right. Yeah. So, so that's a lot of energy. But imagine, so you can't tap the water like this by just throwing energy, brute force in it. But now imagine you realize, oh, space-time is like a fluid, and it curves when it spins, right? When the water goes down the drain, it doesn't just go straight down the drain. It spins, right? And that's what makes it curve. So now, instead of tapping the water in your bath, you could just put your little finger in it and just spin it a little bit, and the water would start curving. You would start making a gravitational effect. So you can imagine that using these new equations, you have a pretty straight path to gravity control, to like being able to affect gravity in a very powerful way by coupling to this field. If you can couple to this field that's everywhere and force it to spin or get it to spin in a region of space, all of a sudden you could create your own gravitational field independent from the Earth. And all of a sudden you could oppose your gravitational field to the Earth. You could do all kinds of things. that would make it so that you would have levitation. You would have, you know, all of a sudden the capacity to have a spaceship that doesn't require fuel to get out of the atmosphere, that you could go to Jupiter for the weekend, you could explore the solar system, because you're not relying on fuel, you're relying on the structure of space-time itself.
Now, 30 years ago, the mainstream theorists essentially were talking about gravity instead of as a wave, as gravitons, which we all know is nonsense now. Same thing with what you're talking about. You know, like you mentioned earlier, and I said at the beginning when I was introducing you that you have been published by these very, very well peer reviewed journals, that they're
Mhm.
finally accepting this. But those that refuse to accept the fact that we have the ability to affect gravitational change, what would you say to them? That is there anything that could really be said to them other than displaying something that can produce gravity?
Well, you know, I mean, of course, well, first of all, you'd have to show them the equations why you could. And I've got that.
Hmm.
But but more importantly, I think it's an optic that people have. You know, if you only went 100 years ago or 150 years ago, and you told a a man on a horse, because at the time there was only horses, right? That only a few generation, you know, 150 years in universal time, that's like seriously nothing. It's not even a second of a universal time, right? So if you told a person 150 years ago that only a few generation, like his grandson would get onto some metal object that could fly to Australia in a few hours, he would it would they would totally think you lost your mind, right? Like you'd get burned at the stake if you were a woman, that's for sure.
Yeah.
You know, I mean, it was not like even close to the consciousness of a person of that time that you could get metal to fly, right? Like that's like completely insane. And now today we do it like daily. We don't even think about it twice. We pack like a few hundred people on a metal object and we send them away to Australia, you know, and they land a few hours later. I mean, a few hours, 15 hours or
Yeah.
20 hours later. But, you know, we do it all the time. It's the same thing. I mean, clearly, we built a whole civilization from the guy on the horse to today because we learned to control electromagnetic fields, right? As a result of Maxwell's equation, as a result of Faraday, you know, and many others, we learned that how to control electromagnetic fields, get electrons, electric fields, charge from, you know, magnetic fields, and all this stuff. We figured out how to use all this to like run all of our devices, like, you know, our phones or communication, like the internet, your car, everything. So the next step for humanity is to learn to use gravitational fields. And actually, it's not only like a cool thing we need to do, it's critical. It's the only thing that will, you know, including extracting energy from that field, that will give a chance to humanity to survive. It's critical. We're running out of time. We're running out of resources. We're running out of ecosystem to destroy. I mean, we are in serious trouble. Like we're on the 11.9 hour, right? Like
Hell yeah.
there was reports that were published a few days ago about the state of affair of our biosphere, and it wasn't pretty. We don't have, you know, 50 years. We don't have 20 years even. We're like at that tipping point. So it's critical that we learn to do this immediately.
There was a scientist that I spoke to not too long ago who basically said once that the humanity globally can accept that we can affect gravitational changes, things that
Mhm.
are science fiction will literally be thrown out the window and become science fact. He
Right.
also did
And
say that imagine if humanity is a pie, right?
Hmm.
And the missing slice is gravity. Once we
Hmm.
complete that pie, then we can move on to become the civilization we're destined to be.
Yeah, it's a done deal. As soon as that's very good. I'm glad to hear that from another scientist. It's absolutely critical. It's the piece that's missing, and we're finally getting to it. I solved it. It's in my windows right now in my laboratory because I ran out of space on my blackboard, on my and so But basically, it it it's critical. And it's like, if you want to know the future, you can look in history and you'll see, is there anything that preceded all of the advancement we have in technology today? And you'll find, yes, there is. And we called it science fiction, right? Meaning science fiction has always been ahead of science. Like, why? Because anything we discover and invent has to be in the imagination of a person at one point or another, right? And so, like, refrigerators, cell phones, you know, uh, cars, rockets, all, like, satellites, all this stuff was in science fiction before we it became science fact. Um, and computers and so on. And so basically, if you want to know where we're going to go if we make it, well, you can look at science fiction and get a pretty good idea, right? And if you look at science fiction today, most science fiction movies that are futuristic have, ships that are able to go across the galaxy or across the solar system, or and they're not running on fossil fuel. They're not, there's no gas station you got to stop in and refill. And so, although the science fiction, and they talk about wormholes and going through wormholes and black holes and all this stuff. And just to be clear, wormholes and black holes are not just science fiction thing. They actually are predictions from Einstein field equations. So these things are real, and we know they're there. And what we are going towards is our capacity to do exactly what we saw in science fiction. Now, the thing is it can't happen in 10 generations from now. It has to happen in our generation. It has to happen in the next few decades. And so, not necessarily wormhole travel, because that's probably a little more advanced, but at least control over gravity, so that we can birth our civilization into a space colony and colonize other planets in our solar system, and hopefully start traveling in our galaxy and so on. I mean, as soon as you have gravity control, everything changes very dramatically. You can go to Jupiter for the weekend. It all becomes available to the public in at large. Of course, right away, it's not like all of a sudden you're gonna get a red button in your car that makes your car levitate. It's not gonna happen that way, But the planes could start being replaced by a very large spaceship that can take a lot of people. The transportation system of our planet could go into gravitational control ships, so that we're not trucks everywhere and train. I mean, it's time to, like, get past this and start taking the cement off the surface of the planet and start moving in the air, in the atmosphere, and beyond in space.
It blows me away. We have Elon Musk, a very, very smart engineer today, a billionaire that he owns Tesla, of course, SpaceX, and what is he still using for rockets? The same thing the Chinese people were using, what, in 800 AD, 1200 years
Exactly.
ago, burning chemicals to go up?
Right. It's not advanced very much neither. I mean, he's done most of the advancements on rocketry in a long time, and it's not very advanced. I mean, it's literally what the Nazis were using during the Second World War, design. And, it really doesn't do the job. Like, to go a few miles up, we burn, millions of tons of
Fuel,
fuel,
yeah.
like, in a year, to put a few satellites up or to refill the space station. It's really crazy that there is not so much, and that's a really big problem. Like, the investment right now should be in gravity control. There's NASA that's doing a little bit of an investment. There's a few folks, Sunny, at NASA, that are doing some research in trying to warp space time. Vacuum fluctuation. I mean, there's some serious people trying to go towards gravity control, but in general, these efforts are not supported, and that's the problem. Like, it's just not gonna happen with garage inventors. It needs serious labs. I mean, garage inventors, don't take me wrong, they do a really good job, considering. I mean, there's a lot of really cool stuff that comes out of garages, but this requires a serious investment. And it's just sad if a very small portion of the funds that are going to, for instance, accelerators or rocketry was diverted towards gravity control research, we would have gravity control by now.
I'm actually glad you mentioned that we would have gravity by now. Not too long ago, I interviewed a Forbes astronomer, astronomer, and what he basically said that if because of course he wants to stay within what the mainstream and what Forbes wants to talk about. He said
Right.
if we really put enough quantum physicists right now working round the clock,
Uh-huh.
for a couple of years, we would solve the ability to control gravity. And then we could finally start to go to other planets, terraform them, and live there and beyond. We could finally become a type 1 civilization, or is it a type 2? I believe we're still a type 0.
Right. Right. I have a tendency sometimes, let's not get political, but let's just say sometimes when I look at our representatives, I'm thinking maybe we're type -1 at this point. But, it really is, and I'm just joking, there's plenty of great people out there, but I just, yeah, I like it. It's really kind of critical that people understand that, this is not like a far-fetched thing that, like, would like maybe happen, in like 300 years from now, or like, you know it's not. And if we can't get there, then nobody's gonna get there, because we won't be around if we don't get that. This is our chance. It's like our escape pod. As soon as we have access to space in a routine way, in a way that's easy to access without burning thousands and thousands or millions of gallons of fuel, um, then we have access to almost infinite amount of resources. There's chunks of ice the size of continents out there. The asteroid belt is full of minerals and everything you can think of. I mean, this we're finding more and more planets around stars, like everywhere we look, even in the stars that are very close to us, 4 light years and so on. Like, we're finding, planets around so many. uh, I mean, in 2013, the estimates of livable planets. Those are planets that are in the Golden Lock region, in the region where it's not too hot, not too cold from their star. Um, the estimate at the time was 40 billion planets in our galaxy alone. That's in our galaxy. That's it, right? And since then, we realized that we had messed up our calculation on the amount of stars in our galaxy, and it's twice the amount that we thought. So that would make it
80.
80 billion livable planet in our galaxy alone. Like, never mind the 2 trillion other galaxies in the universe. So, it's insane the amount of like resources that are out there. And of course, energy and all this is all tied into that. And so it will liberate our humanity as much as the discovery of planes liberated humanity from having to transport things with boats and trains and stuff, and made it possible for intercontinental relationship to be developed and all this, and make it possible for the average human being to travel around the world. This is only in a few decades, in a few generation from the Wright brothers. It advanced very fast when a discovery is made, and it's just one individual or a few individuals discovering something fundamental and then having the means of getting it into the world. I mean, you would think that this kind of effort would have enough appeal, both financial and humanitarian, for billions of dollars to be poured towards that research. And it always boggles my mind that most of the inventors and scientists that are working on these kind of things struggle to be able to buy the equipment to do the experiments.
How, as you mentioned, how the Wright brothers and their invention changed the world so drastically, how we can have relationships with other foreign leaders, etc. Just before the Wright brothers, if you wanted to go on vacation, you were going to stay for a couple months. I mean, you had to take, if you wanted to go to France from Los Angeles, you're packing trunks, right? It's just a little suitcase. Now, we could fly there and have a weekend in Paris and be back here by, 3 days
By
later.
Monday work. Yeah.
Right? Absolutely.
Yeah,
Now,
yeah, yeah. I mean, especially from LA, now you have direct flights to Paris. They're red eyes. You get on at 8 at night. You wake up in the morning and you're there.
there. That's right. That's right. Now let me ask you this: is now because this happens right away, right? It didn't take long after the Wright brothers to start using this technology in World War One. I mean, it's like less than what 6 years, something like that, is
Right,
from
right,
the
right.
Wright brothers.
Well, yeah, but even but even so, it's important to know that even after the Wright brothers flew the first plane, and I want to put a little bit nuance on this. There's evidence that there was others that flew planes before that, but the Wright brothers got the credit. But that they are, the scientific community for almost 3 years after the first plane had flown were continuing to publish papers uh, proving mathematically that it was impossible to make an airplane. And so they were publishing these papers before the Wright brothers, showing that no way because you think about it this way. I mean, I guess these scientists didn't get out of their laboratory very often and noticed that there was birds and bees and all this stuff were doing it every day. But for them to think that you could, have like motors that are super heavy, right? They're super massive, that would produce enough air turbulence that it would lift themselves off the ground. That sounded like over unity. That sounded like magic. Like and they could mathematically, prove that it could not be done. And many hundreds of papers were published, discouraging inventors. And so because of that, the governments were not investing millions of dollars in plane research and trying to get a first plane off the ground. The industry wasn't, investing millions of dollars to get, like, to make the first plane. Nobody was financing this stuff, and it took two brothers that had a bicycle shop tinkering in the back of their bicycle shop and using, the beaches of a lake to for their runway to get a first plane up, right? Like, without the garage inventors, it wouldn't have happened. Because all the mainstream was saying it's not possible, so nobody was going to invest in that.
And that's sad because we do need to invest in R&D. That, I mean, like we said earlier, as you mentioned when we talked about science fiction, it has to become science fiction, and until someone in their head, until the idea for something comes, and then people implement it. Have you ever been contacted to consult with companies such as Bigelow Aerospace, or even, as I mentioned, Elon Musk, SpaceX, or Tesla, or anything like that? Any of the new companies that are making major leaps in aerodynamics, like Boeing, or in space?
Um, yeah, I mean, yes and no. I've been contacted by various companies to help with certain things, and I've been contacted by certain governmental organizations as well. But these things, like I said, it's just like the same situation as the Wright brothers were in. The context is such that if you say, here's the map to control gravity,
Mm-hmm.
and the physics that you're writing is not the accepted views of physics, which the accepted views of physics are struggling to find a unified field theory, right? Like, so of course, when you find it, it's not going to be the standard physics, since the standard physics does not have a unified field theory. But never mind that. So you deliver the goods. You say, here it is. There's the roadmap. That's how it can be done. The investors, the interested party, and all this, they turn around. They give you those physics to the standard physicists, and the standard physicists go, oh, this is crazy, it's not standard, right? And and just like at the time of the Wright brothers, nobody, like, people are afraid to get involved in financing this thing. So movement forward is slow and painful. It's like, okay, making a plane in the back of a bicycle shop is hard, but it's doable, right?
And we saw it being done. That's the way. That's how it started.
Yeah, it happened, right? Making a gravitational drive in your garage is a whole lot harder, right? Because it's not just like bicycle chains and motors, right? It's a little more complex. And so it requires more complex equipment, higher energy levels, all this stuff. And so it requires a larger investment. Now, are we going to get there? We are. There's no doubt about it. Are we going to get there on time? I don't know. That's going to depend on if people light up, people like Elon Musk and Galactic, Virgin Galactic and those guys, and they finally get that, like, yeah, the future is not in large cylinders full of fuel, but actually into understanding gravity and controlling it. This is very, very important.
Now, one thing that we know generally that happens, that most of the R&D, the research and development into most of what was once a theory and then was proven to be fact, starts at the top of the military levels. And
Right.
do you think that's where this is going to start with before it finally trickles down to the rest of the world that's going to be able to use
Uh,
something, maybe a reactor of some sort that produces gravity?
Yeah, well, it's already started a long time ago in the military industrial complex, and there's lots of evidence of that. But so it's not like the military industrial complex has been like saying, "Oh no, we're not going to explore the possibility of controlling gravity," right? It's not, just recently the military industrial complex released a bunch of files that to the public and basically disclosed that UFOs are real and people better get used to it. I mean, that's literally the title of some of these headlines that came from the the the
DOD, right?
yeah,
Department
yeah,
of Defense. Yeah.
yeah, Department of Defense. And I mean, so it's not like they haven't for a long time. And it's funny when you when you read those articles and the briefings and all this, they're talking like this is a new phenomenon. They got to figure out what all these objects that are invading the airspace is doing. And it's known, it's very well known that it's been going on since at least the Second World War. But I'm sure that they've been investigating inside those, in some cases that's why I was contacted. But this is not. I'm people I think give too much credit to the to the military industrial complex. And I say that with humbleness. There's a lot of good people there, and there's a lot of good people there that are working for the right reasons. I mean, people get involved in these organizations because they want to do something positive and significant for the planet, as well as protecting their family and so on. So there's good people there. It's just that we have to, basically, the problem is that these people are educated in the same physics as everybody else and in the same mentality as everybody else. And in order to solve this problem, we can't solve it within the context of the what is already known. This is something Einstein pointed out early on, that you can't solve a problem within the same context in which it was created. And so, like, I don't know how much creativity occurred there to solve this problem. I believe they got some results. I don't know how far they got.
You actually took the words out of my mouth that physics as we know them are wrong. And like you mentioned the DoD videos and files,
Mhm.
some of what the pilots were seeing, the only way you can account for the way they're responding, moving,
Mhm.
or even as some suggested, one of them that the from the USS Nimitz to Commander Fravor, what he was seeing when it was underneath the ocean looked like a time dilation, and
Mhm.
it's been explained that the only way that these things are moving, because it's not really proper to say flying because they're really not if they're enveloped in a gravitational field, is because of gravity. And that's
Mhm.
when it comes back down to the basic thing that I was saying earlier, where I was speaking to that scientist, where he said, once we get that final piece of the pie, gravity, it closes the whole pie for us. And that gives us the next leap to, of
Mhm.
course,
Yeah.
spacefaring technology.
Right, for sure. And clearly when you listen to these videos, they're great because you hear the reaction of the pilots. I think it was the Navy in this case.
Yes.
and there's a lot of F words and there's a lot of what the hell going on.
Yeah.
And it's like, well, it shows clearly technology that is, well, so like, first of all, if there's passengers in there,
Mhm.
you see these objects doing like very, very sharp turns, like if not like exceeding 90-degree turns at velocities that are insane. And so the g forces in there should kill everybody in
The
there, right?
inertia. You're talking about the inertia, right?
Yeah, inertia in the inside. You should be plastered against the ship, like, like a big spot of blood. You shouldn't be surviving this. Um, so clearly, let me put it this way: the acceleration of these objects is not applied to the object as a whole, but to all of the particles in the object. Meaning, it's not like the ship is moving and you're being transported in the ship. Is like all of the particles that make up the ship and the passenger and everything are being accelerated at the same time. So basically, space time is modified in that region so that all particles are moving in the same acceleration frame. So of course, if all the particles are moving this way, and then they are all of a sudden moving this way or this way, right? There's no force felt on the inside of the ship. Nothing is being splattered against the ship. The only time that you feel the g-force is when the ship is moving as a whole. The ship is accelerated, but not the stuff inside. So then it's being accelerated, and since you have not caught up to that acceleration, you're getting pushed against the side of the ship, right? Or the seat or whatever you're sitting on. And so clearly, the only reason these objects can do that is because space-time is being modified. The acceleration is not coming from propulsion, but by the modification of space-time in that region.
Some people have also even theorized that consciousness can even control some of these objects, and
I wouldn't
that's
be
what we're
surprised.
leaning to.
Yeah, I wouldn't be surprised, because remember, the equations I wrote show clearly that the end result of this information field, right, that has feedback in it, produces self-awareness. So I wouldn't be surprised if you could, like, imagine, so you have a ship, the drive of the ship is producing this toroidal feedback loop field very strongly. It's like you've made a large consciousness bubble. You can think of it that way. And imagine you create, you have a computer or some kind of automation that makes it so that your consciousness or your awareness, your feedback becomes part of that larger feedback. So all of a sudden, it's like you've expanded your awareness to the side. Instead of just being your body, and then you think of moving your hand and your hand moves, right? Well, all of a sudden, it's like you think of the whole ship moving and the ship moves, right?
That's right.
Because you're part of the feedback that's driving the thing. So I wouldn't be surprised. I wouldn't be surprised at all. I think it would be a natural consequence of the evolution of this type of technology. I guarantee you. When think about it this way: if there's 80 billion habitable planets in our galaxy alone, I guarantee you some of these planets were there long before us.
Oh, yeah. Even a million or a billion years or 3 billion or 10 9 billion.
Yeah, exactly. So what does your computer looks like, 1,000 years from now? Never mind, like 10,000, 100,000 years from now, right? I mean, it's like, I guarantee you're probably not operating it with a keyboard and a mouse anymore, right? it's probably linked to your brainwave frequency, and you can probably just think of something and the computer does it, right?
And we do know that the military industrial complex and some of these bigger corporations that are investing a lot of money into these concepts are starting to play around with techniques of having your brain literally thinking of something and controlling.
Yeah, actually, that in the 80s, 90s, early 2000, there was a lot of declassified material about how they were trying to get pilots of jets, because the response time is too slow, because the jets are going so fast, um, to start to be able to control the plane with their thoughts, or at least where they're looking and so on. And uh, and it was great, except that if the pilots became emotionally disturbed, then it was not so great. And because they were, there was all sorts of interference. They weren't getting the right state. They weren't in the right state to, like their eye movement would start to flutter, all this stuff, and then the plane would like not behave very well. So then they started to train their pilots in meditation techniques and yoga techniques and all this, so that they can stay calm in stressful situation and all this. And that's all good, but this is hearsay, but I know that I believe that some of the result as well was that some of the pilots were no longer willing to go to war, as a result, because they became enlightened or something. But this is something, of course, that's been explored, and we're just in the beginning of it. But I mean, look at how fast computers have advanced in the last few years. I mean, in the last 2 decades, it's been incredible. 3 decades. Okay, let's give it 30 years. I mean, it's unbelievable. Nowadays, we don't think twice. We get an SD card that is like, so small. I got to put my glasses to try to read how many gigabytes it is, right? And it's got, like, I don't know, 64 gigabytes, 128 gigabytes, 512 gigabytes.
Or a terabyte. It blows my
Yeah,
mind.
on this teeny little thing. This was inconceivable 30 years ago. Inconceivable.
It seems that we're going towards nanotechnology now.
Hmm. Sure. While things are getting smaller, we can pack more and more stuff in a smaller and smaller package. Yeah, I mean, it's gonna get powerful. It's just what are we doing with it is important.
Yeah, and unfortunately, I really hate when it comes to the point of using technology for war. And I've noticed that the more that you separate people from the from seeing the violence, for instance, right? If in World War II, if say you ran out of bullets and you were, in danger, what would you do? You would have to face someone with a knife. I mean, you're face to face when you kill someone. That really affects you. Well, now you have 18-year-old kids straight out of high school in Nevada sitting in little containers, and they're flying drones from the other side of the world, dropping Hellfire missiles, killing 30 people, going home and sleeping at night, thinking it's a video game. That's really
Right.
sad.
I know, it's unbelievable. It's remarkable. If we could divert just a small percentage of the creativity and the engineering and the finances that go in making better and better ways of killing each other, we would be such a better society to live in. It's so sad that we still do this. It's so sad that, from discussion I have with people that are part of the military industrial complex, that, like, you know all the time. As soon as you start talking technology, the first thing that comes to mind is how can we weaponize this? And it's just like, wow, what is so critical in you needing to kill each other? Now, I'm just gonna put a caveat in there, and that is that, first of all, the people that do these things are not necessarily bad people. They got involved because they wanted to help. They wanted to, be guardians for their family, for their nation. It's important to understand these are human beings with kids and families and so on. But as well, and what's important to understand as well is that as we discover this new level, if we can get there, a lot of the stressors that we have that produce most of the wars we have will go away when we can extract almost an infinite amount of energy from the vacuum of space, from the structure of space-time, and we're getting really close to that. Like we are, like, when we are able to get as much uranium as we want, or as much like gold as we want, or diamonds as we want, whatever, like as we explore a solar system, whatever, um, we the need to fight for resources will go away. One of the largest stressors in our society that has produced most of the wars in the last few decades is the need for oil.
Fossil
Well,
fuels, right?
fossil fuel.
Exactly. And
Yeah.
and like you mentioned, if we had access to all these other planets, then we can get not just gold, diamonds, etc. We wouldn't have to touch anything on Earth, but we might be able to discover some of these new elements that are not on the elemental chart, heavier elements, and I just it blows my mind how much there possibly can be for us to access once we start to be actually go visit some of these Goldilocks planets, or moons of, say, Jupiter, or even the asteroid belt.
Yeah, or never mind, having an encounter with a civilization that has millions of years on us. What could we learn? But the problem is that we probably would be given this kind of knowledge if we were pacifists, but most likely advanced civilization that find a planet like ours would probably sit back and wait, before they give us anything, because it's like you don't give a gun to a 3-year-old. You don't give a loaded gun to a 3-year-old. It's like there's a good chance they're gonna hurt someone themselves or whatever. Like it, so like this is it's like a conundrum we're in, and the key to this conundrum, the only key to make this transformation happen. I'm very serious about this. I've been thinking about this for a long time. Like, is there any other way? The only key required, the linchpin for us to change and transform, is tapping into this almost infinite source of energy that we call space-time, and learning how to control it to produce gravitational field. Like, that will change everything. All of a sudden, the need for oil, the need for all these things. I mean, like, imagine when you can extract, like, the amount of energy in space time. This is standard. It's called the Planck density, if you want to look it up. Is 10 to the 93 grams per centimeter cube. It's huge. The mass of the universe is 10 to the 55 grams. So that would mean that in a centimeter cube of space, the energy available is 39 orders of magnitude larger than the mass of the energy of the universe. Like, so imagine this is in a centimeter cube of space. So, like, if we get to extract 1 billionth of a percent of what's in there, that would run the planet for thousands of years, just from a, So like, oh my God, like there's so much energy. Clearly, the universe we live in is not a low energy system. Like, look at all the stars. Look at all the, like, right here, right beside us, the sun is burning continuously for millions and millions and billions of years. Like, this is not a low energy universe. This is a high energy universe. We just haven't figured out the source of the energy. And now we're starting to realize, wow, it's everywhere. Okay. Now we need to tap into it and save our civilization.
You also read my mind there when I was just about to use that same word, Nassim, tap. That we need to learn to start to tap into it. Now,
Yeah.
I when you mentioned earlier that it's the if a civilization that is advanced enough that has its technology that is watching us would not intervene, and you mentioned that it would be equivalent to say giving a loaded gun to a 3-year-old because they would hurt someone or themselves, is very true because I believe that our technology has come so fast that I think most of us sadly are not responsible enough yet for the technology we have access to. And so many of us are using technologies, yet we didn't create it. And that's what, because I think because we didn't create it, yet we have so many different toys, you can call it that, whatever, toy technology, that we could use, then I think we don't understand the magnitude of what is really behind them. For instance,
Right.
you have an iPhone right here, right now. I know how to
Mhm.
turn it on. I know how to call. I know how to speak to it. It'll talk back to me. It'll tell me if I play some music. But if I take it apart, I don't know what the hell's going on there. And I think that's why it's so easy for someone to, and unfortunately, take advantage of that.
Right. Well, yeah, and your phone is a good example. You know that that your phone is not the thing. Meaning, the thing is that there's electromagnetic waves in the space that's making your phone able to talk to another phone, right? So you see what I'm saying is that, so for instance, we think the brain is the thing that makes consciousness, and what I'm saying is that no, the brain and the whole body is like an antenna tuned into a field of information. You see, and so yes, like one of the reason that we are in this situation is that people don't necessarily understand the intricacy of how to, like, how your phone works or even how your car works. They just drive the car, they just use the phone, and they don't necessarily understand the intricacy of what happened when they fuel the car, what happens when it's released into the air, when, like, the technicalities. And then so it's easy to debate these intricate, difficult scientific question and say, well, carbon release is not significant enough to do any warming, or to start to, like, create doubts in people's minds about what's being said in science, when science is saying, wait, we got to do something different, right? And most scientists agree, but then there can be enough doubt being inserted in people's mind that they start thinking, oh, maybe it's not, I can continue to ignore that, right? It's like, it doesn't matter how many electromagnetic fields I'm living in because of my telephone and all this, because, right, there's studies showing it, it produced cancer and all this stuff, but there's debates about it, so I can ignore that, right? Meanwhile, the cancer rate is going through the roof, right? I mean, it's horrible. It's remarkable, and the Earth is warming up.
Yes.
Yes, and and the reports that came out a few days ago was is extremely dramatic. But it's true. It's not just the Earth that's warming up. There's other planets in our solar system that are warming up. There's a change in the solar system temperature. That's okay. That doesn't mean that the compounding effect of all the carbon we're releasing in the air is not making it worse for us and giving us even less time to react appropriately, right? So it's like, yeah, you're right. It's hard for the general population to understand the details of all this, and they are relying on our representatives to tell them what's real and what's not. And the representatives are not necessarily scientists, and most of the representatives, because of the system we use, are associated with very large corporations and military industrial complex and all this that have their own agenda.
That's true. They actually do. And when you mentioned about the Earth warming up, you know as well as I do, Southern California has had the hottest last couple of years. I know in 2018 they said four of the hottest years leading up to 2018 were in order: 2018, 2017, 2016, and 2014. We
Right.
know this year is not going to be very different. In the San Fernando Valley right now, it's 109 degrees. We
Yeah.
know that on the East Coast that they've had to add another level of hurricane. So instead of level 5 being the largest, there's level 6. These massive changes are going around us.
Yeah,
Back
look
in
at Europe. Look at Europe. It's been under a heat wave for the last month and a half. I mean, they're burning over there. It's intense. And all this, if you look at the graphs that were prediction of temperature change in all of the papers, or most of the papers that were published on climate change in the last 10 years, they are exactly on target. Actually, it's accelerating faster than the graphs. Um, I think they were predicting by 2027 that I can't remember. But like that, basically in all of the largest cities, the average uh, temperature of in the day in the summer would be the warmest temperature that the record temperature that they were recording in the 80s, right? So I mean that would be the average day. So I can't remember. I don't quote me on this, but it's around those lines. It's we're getting there.
Yeah, I was just gonna say, I actually do think, because I remember the temperature in the 80s. I remember it was never nearly as hot, even in the hottest months, and in the 90s, nowhere near. But yet here we are, 30 years later, almost 35 years later from the mid 80s,
Mhm.
and yet I think that we are. That each day now is what it used to be at the record temperatures. It was in the 80s, every time it broke over 100 was a record setting day.
Mhm.
102, 105, 170 degree Fahrenheit days are the regular now. And that's a scary thing.
Yeah, it is, and it's exponential. It's not a linear, so it's getting worse fast. And yeah, I mean, it's like HVAC systems is a significant part of the energy consumption on the planet, and it's gonna continue to go higher and higher. Like we're talking, like significant amount of energy has to be produced to keep people alive. Because at these temperatures, you die from heat stroke. So it's getting critical, and we have to find new sources of energy. And there's a source of energy that is running the whole universe that's right there. We just got to invest in tapping into it. Like, oh my god, like since at least since Tesla. And like Tesla is probably the greatest inventor in history of of inventions. He invented almost, a good portion percentage of the devices we use today is the result of, you know either direct or indirect, you know Tesla patents. And Tesla was clear at the time that we had to, tap into the ether, tap into this energy. And he was very upset with Einstein for having removed the ether from physics theory, which Einstein smartened up later on, but it was kind of too late. But yeah, I mean, this is Tesla, generations ago. Now we're like on the critical point. It has to happen now. So industry needs to invest in this possibility, because it won't matter to anybody anymore if we don't overcome this. It's not going to be people think, oh, it's going to be generations from now. No, 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 no. It's going to be your kids.
Generation.
Yeah, it's going to be you, it's going to be your kids and your grandkids. They are going to eat it. They're either going to survive, or because we do something significant, or they're not. Like it's not generations from now. It's not like that.
Oh, you're absolutely right that I don't even think it'll be people who are having just now grandchildren. I don't know if their generation will survive because the generation before them, the children of the future right now, I can't even picture what it's going to be like for them in 30, 50, 70 years from now. It's very, very scary. Let me ask you this. Has any of your work or any of your theories or anything that you've worked on been able to help with the medical technologies?
Yeah, for sure. Yeah, of course, because as you learn how to engineer the vacuum, so clearly, if this is all true, and there's a lot of evidence it's correct, um, biological entities and health is the result of the assembly or the movement of information through that system. Like you're in antenna, and there's information moving through this system. You're not like only receiving, you're sending as well. So you're like a transceiver. And so, how efficient the transceiving is occurring is going to determine your state of health. It's like your radio set, and the dial is either on the station or a little bit off the station, right?
Hmm.
If it's off the station, it's like you can't hear anything. You might get a little bits here and there, but it's like a lot of noise, and the system is not very coherent. But then if you tune it to the station, then boom, all of a sudden it's clear and you can hear the football game or the music or whatever. And so it's like that. Your body can become detuned. Your antenna can become detuned. Why? Well, because of all the toxins that we're exposed to, because of the food we're eating, because of all the things that happen, the emotional state of your consciousness, like you broke up with your girlfriend, or you're having a hard time, at work, or you're having a hard time in general. You're just completely depressed. Like your antenna starts going off the dial, then there's a lot of noise, then things are going to start breaking down just because they cannot communicate properly. So then cells starts to multiply out of control, and you got cancer, or you got, like all kinds. Your immune system drops. I mean, the immune system of most people is so depleted at this point because we're exposed to so much stuff, from electromagnetic radiation pollution to like so many different things, toxins, radioactive material. It's very, very. So yeah, of course, if you make a device that's creating its own coherent field in the vacuum, like you're making a large vortex in the vacuum that's highly coherent, then you can retune your antenna. You can make devices that doesn't make such a big vortex to like lift off a ship, but that makes one that's more directional, and maybe you can apply it to a person. I start to play with these ideas. I've developed crystals that do that. Like I can manufacture crystals that oscillate a little bit with the vacuum. They create a little beam of vacuum photons. We can measure it, like we continuous photon emission from these little crystals, and that produce a little coherent field, and it helps with your health. You know, but this is just really the first few steps. It's very, very beginning. But yeah, they will be incredible application to health and to life extension, like, because basically your body becomes decoherent as you get older.
Mm.
If you're able to create a field that's highly coherent, you can recohere your body, right? Then you could think of a body functioning absolutely fine for hundreds of years. It's totally, it all becomes possible.
To live longer and rejuvenate yourself. Absolutely, I do believe in those. There's some questions for you, and I'm trying to get
Okay.
everyone to copy and repaste them. This one here is from David Samuel Peckinpah. I think I said that right. Do you think technology is now quite literally forcing this outside of human hands in many ways?
I don't understand. That technology is moving is what is, oh, that is he talking about artificial intelligence or?
He doesn't. There's nothing before here. Let me see.
Okay, repeat the question again then.
He says, "Do you think technology is now quite literally forcing this outside of human hands in many ways?" I don't know what that means, forcing. Okay, let me. Maybe he'll hear this and he'll write something else. Let me look for
Yeah,
another question
maybe
here.
we need you to ask the question more clearly again, because I'm maybe I missed something. I'm not getting
Yeah.
it.
David Samuel Peckinpah, please rewrite that. Let me see if I find something else here. Um,
You might be thinking
what's
that
this?
technology is forcing people to this kind of like this kind of development to occur in some, whether we like it or not. I mean, in some ways, yes. I think that like we are starting to. I mean, like technology is kind of advancing on its own, and it's gonna it might get us there against our own better judgment. I don't know, but what I know is that it's gonna require an investment from society to realize that this is something that has to be supported and made available.
Before I ask you this next question, you mentioned something when you were responding to this last question. That's something I should have asked you about. What's your take on artificial intelligence? Because I've heard Elon Musk say it's the most dangerous thing and that all his attempts to tell people to stop have been futile. I've interviewed two separate people who are involved with artificial intelligence. One said that the computers between speaking to each other, communicating with each other, were showing signs of hiding secrets when communicating with each computer. Another one, another test was showing that these computers that were communicating secretly without the masters being us, they wanted to eliminate the masters. And that's a very scary thought, to give technology, an artificial intelligence, to have them the ability to live on their own, make decisions on their own. And if they're plugged into our internet, they control the world.
Right. Well, it's a difficult question. I'm of, maybe because of my age, of the opinion that, first of all, we're very far from an autonomous, self-aware device. I, 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 I would I would argue that it's going to take a lot more than data crunching for a thing to become aware, and that that's because as well, the terminology artificial intelligence is kind of a misnomer as far as I'm concerned. Like intelligence cannot be artificial. Intelligence is intelligence, uh, and intelligence is more than crunching data. Intelligence is a state of emotion. It's a state of being. It's a state. It's more than just like data in, data out, right? So the probability, so it's a more complex thing than just a computer that's fast enough. Um, so now, does that mean we're never going to achieve artificial intelligence, or what they think of as artificial intelligence or intelligence? I mean, in a device. I think we will get there, but it will be as well as a result of tapping into this infinite information field, because we're going to reproduce what naturally happens. And so it's not going to look like a computer like we think of a computer today. It's probably going to look more like a plasma that is interacting with the vacuum at a high rate of frequency, and that's producing feedback. um, I think that fundamentally, that type of computing, when it occurs, if it produces intelligence, it will be intelligence is naturally self-preserving,
Hmm.
uh, and naturally benign. That's my feeling. And you might say, well, the state of this world contradicts that. I would argue that that's not true. I would argue that most people are born benign. Children are not born evil. They're not born thinking I want to kill other people. They don't. That's the result of the distortion of what we put people through. So if we were to produce a pure source of consciousness in a device, I think that device would be benign and it would be supportive to us, not wanting to destroy us. So I disagree about this fundamentally.
And whenever it comes out, by the time regulations and everything else and the laws, it takes like a decade. Look at the cars putting seatbelts on, right? How long it took for automobile manufacturers to finally put enough regulations for put a seatbelt on. It took over a decade. So once that breakthrough comes, it'll be so overly regulated, and to tweak it until it's proper, it will take at least, I think, several years, if not a decade. There is another one here that I can't quite pronounce the words. Maybe you know them. I'll try it. If it doesn't work, don't worry about it because we are pretty much out of time. This is from Rolf Pfeiffer Muller. He says, please ask his opinion concerning Satyendra Nasbase and Einstein condensate and the Satyendra himself. Do you know what he's talking about?
Yeah, Bose-Einstein condensate is what he's
I
asking about.
believe so. Satyendra is Satyendra.
Okay, but I mean, I think he's talking about, yeah. My opinion on this is that it's going in the right direction, and certainly, the concept of Bose-Einstein condensate, the capacity to produce them, is going in the right direction. Basically, what is critical is that we create a state in a plasma or some kind of high energy compound in which we are able to create a highly co-moving, self-organizing system that can go into a resonance link to this fundamental field. And when we do, now we are in. It's like tapping into the universal net, you know?
Hmm.
And then when we're in, then we can control what the structure of space-time is doing. So I'm not necessarily familiar exactly with the rest of the question, but certainly I think that Bose-Einstein condensate is on the in the right path, in the right direction to getting the job done. Um, and basically, a Bose-Einstein condensate is a plasma state of a system that's been cooled down to extremities, to extreme temperature, in which the particles start acting as one system instead of independent particles. And so uh, this is related as well with entanglement and the capacity to have action at a distance, which Einstein calls spooky action at the distance, and all this. And this entanglement and the fact that we can act on particles at a distance, no matter how far they are, has been verified in laboratory. So basically, the whole universe is entangled. It's connected, and we're slowly starting to discover this. And when you do something here, something else gets modified, you
Hmm.
know, on the other side of the universe. And so to start to understand how that whole works and tapping into that universal network is what I've been talking about. And we are getting close to that.
You mentioned what we do here affects something or is happening on the other side of the universe. I've actually heard that as vibrations, or even sometimes people try to implement or apply string theory to it. Is that proper?
Sure. Yeah. Yeah. I mean, string can be applied to it. That was certainly an attempt. I think string, as I predicted, failed. But I think the principles under string is just the formalism that was used was not appropriate, but the fundamental concepts of string theory, I think, if applied to wormholes, micro wormholes, and the quantization of space time, like the two together become very powerful. And I think it has value in that sense, but it's got to be reworked in a different formalism.
Now, your academy, the Resonance Academy, for everyone out there, by the way, there is a hot link on my website. Go to drjradiolive.com and you can click on Nassim's banner and it'll take you right to his academy. Now, Nassim, can you tell people what's going on at your academy and what's next for you and for people that are involved?
Well, yeah, absolutely. We have a course online, you know, that you can take. It's like 6 modules, and it takes maybe a few weeks to go through it. We have thousands of students taking the course at the same times. Like 80 countries are involved. Like so, at this point, like I don't know how many thousands of students have taken the course, and so it connects you to a network around the world of people that are thinking about these ideas and all this, and then you get to learn and you get all the reference and the links so you can do your own research. And it goes from consciousness study to, like, you know, physics and biology and technology and all this, so you get all the information in one place. And every month for 2 hours I answer questions, you know, so that people, all the students, can ask questions, and we all learn from each other that way. And as well, you know, we have throughout the year we have gatherings where the students, we go to like amazing places. We went to Egypt, Peru, Easter Island. Now we're going to Mexico, you know. And it's gonna and what happens is that we get together and we discuss all this stuff, these lectures and all this, but as well we visit amazing ancient sites around the world that show evidence of advanced technology that was probably present thousands of years prior to our written history, and so on. So, we all learn together, and we explore these ideas, and it's really powerful group. And so, and it's a great way to support the research as well. When you participate, it helps financially for us to continue to do research, but as well, it helps universally, it helps globally for you to get into this. And like, every person that changes their consciousness level is making a huge impact on the morphogenetic field of the whole planet. Like, because we're all connected through this whole field. So which radio station are you tuned into, and what are you sending back into the field, right? So yeah, it's a great way to participate.
Now, let me ask you: is there any topic that we missed out on that you think it's proper to touch on before we close the show?
Well, I would like to close that, like, okay, if you want a practical application of what I've been telling you, is like, first of all, become aware that you're bathing in a field of information, that your consciousness is not an epiphenomena of your brain, but it's actually a fundamental principle of creation. And that, like, that the fact that you're there breathing every day is a miracle. It's an amazing thing. It's a very highly tuned system, very highly complex, amazing thing. And that, there's not just the world outside of you, there's the world inside of you. And that to take like a few minutes every day, you can call it whatever you want, like, focus, concentration. It doesn't have to be under the banner of meditation. You don't have to be like in a pretzel. You can just take a few minutes every day, maybe 5-10 minutes every day, in the morning and at night or something, to just reflect on your inside, like open up to like the amount of information that's flowing through you, right? It's not just from the outside in, it's from the inside out as well. So like, to like pay attention to that. Like, it helps you go back to your center. It helps you to find the true source of your consciousness, which is the structure of space-time within you. And I think that makes a huge difference in people's lives. So this is an application that people, can do like today, start, and see benefits right away.
I'm glad you mentioned that because I know a lot of people are doing the opposite, where they're not really looking inside. They're not paying attention to the quiet. They're not even trying to quiet their mind to see what it's saying. So
Mhm.
it's very amazing. Anyway, Nassim, it's always super amazing to speak to you. Before you go, real quick, let me just close up for the show for everybody. Make sure, everybody, you do go to the Resonance Academy banner. Just click on that hot link. It'll take you directly to Nassim Haramein Academy, and I urge you all to sign up. And remember, folks, the only thing you have to do with regards to me is remember the name of the show. That is Dr. J Radio Live. Instagram, Twitter, Flickr, Tumblr, Facebook, whatever you could think of, folks, it's all at DRJ Radio Live. With that being said, this is Dr. J along with Nassim Haramein, and we are signing off.